But if you look at the long-term effects, the cancers and all that, the birth defects, they set it at 1,000-fold. Well, if they told you, hey, you know what, when we use atrazine alone, we saw this level with the hormones and this level with the cancers and birth defects. And we went so far down, 300 and 1,000. What's the problem? The problem is the potentiation, which we have not studied, can go up to 3,000. It could be 30, it could be 3,000, it could be higher. I don't know. But it's worrisome you have atrazine in your water. But what about the 50 chemicals? Will they potentiate atrazine? Will they potentiate each other? Have these chemicals been studied? Last meeting we had here with the EPA, maybe we had 20 people in the audience, and I asked the EPA guy, when you use chemicals in combination, are they not new chemicals to prove it otherwise? Plus, you got 10, so there's A and B, A and C, C and D, the gajillion compounds. He said yes, but each chemical alone, we are below its threshold. I'm sorry, but today's discussion on potentiation, the margin of safety means nothing without knowledge of the potentiation. One more thing. If anything you remember is this. You know that little thing I showed you with the little black box, and you're trying to protect the chicks? And then, heck, you use cats to protect the chicks? That's a stupid example. The cats eat the chicks. That's exactly what science is about, don't you think? The cats eat the chick. What a dumb model. That's what you think. In Maui, my cats, my feral cats I'm trying to control, the cats don't eat the chicks. They're protected by the hens. The rats eat the chicks. So I don't care what you think these 50 chemicals do or don't do. You got to prove it by doing a little experiment, not telling me what you think, just like the cats. Thank you.
I want to thank you all for coming out and sharing this time with me on a Sunday. It's my honor. It's my pleasure to be here. I know some of you I've spoken with as early as 2008, and we tried to figure out how to make this relationship work, and I think we're finding a way. So I'm going to talk to you today about some work that I've been doing for the last 15 years. It's on frogs, and you might be thinking, who cares about frogs? We're trying to get rid of the frogs we have here in Hawaii anyway. But hopefully I'm going to convince you that you should care about the frogs, but we're also going to talk about humans as well. Before I start, it's sort of my tradition that I always do the thank yous and acknowledgements first, so that if you decide you want to kick me out, I make sure the important stuff's done. I've already thanked and acknowledged you. I want to thank Kyle for bringing me out and everybody for showing me a great time. But before I start to talk about the work, I want to thank my family, my wife and my son and my daughter for their love and support. I want to acknowledge my funding sources, and I want to disclose that I have been funded by the manufacturer of atrazine. Trust me though, we're not still hanging out together. I'll sort of give you what I call words from my former sponsor as we go along today. I want to thank all of the students that have been involved. I've worked with a lot of undergraduates. Those people are shown in blue. Wonderful, diverse group of people. Here's a fairly recent picture of some of my students. Many of them, such as Jesus here, and Suzuki, and Wynn, live in agricultural communities, so they were not only just students at Berkeley, they were students whose families and themselves have been impacted and sprayed and working with these pesticides. And just for Kia, there's my Allegheny student right there, Paul. And also this is Sherry Gallipo. She's from Ilo, and she will be the first native Pacific Island to get a doctoral degree in the history of the University of California, Berkeley. She was my student. Hopefully, if things go well, both of us might be moving back here. She'll be moving back, I might be moving here to work at the University of Hawaii. We'll see how that works out. And this is just a list of my current students. And then finally, I want to acknowledge my family in general, my parents, for their love and encouragement and support for the last 45 years of my life. And I want to dedicate this to my grandmother. She passed away in 2005, but before she passed away, she passed on her love of teaching and her desire to make the world a better place through teaching to me. And I'm forever thankful for that. She also taught me how to kind of tell a good story. So I hope I'm going to tell a good story today. So let's just get right down to it. Atrazine, this is it. If you're chemically inclined, if you just have to know what it looks like. It's mostly used on corn. In particular, it's used on GMO corn and experimental corn. It's been used extensively also historically here in Hawaii on sugarcane in both Hawaii and Florida. Sugarcane has been a big use of atrazine as well. It's an herbicide or a weed killer. When I say the word pesticide, sometimes I slip into that. I'll mean anything that kills a pest. So an herbicide or weed killer is just one type of pesticide in the way that I use the word. It's been used since 1958, so it's been around for quite some time. We use 80 million pounds annually in the United States. Until recently, until Roundup, it was the #1 selling herbicide, the #1 selling weed killer. Interestingly, it's also used in more than 80 countries, but is now outlawed in all of Europe. And now, no offense to lawyers, but they're lawyers. Syngenta's lawyers keep writing to me saying it has not been outlawed. It has been denied regulatory approval. Somehow that's supposed to be different. But what I know is that this one pisses them off, so I keep saying this. So we're going to talk about the African-clawed frog. I usually make this joke. They actually have these here in Hawaii. They're originally from Africa. We also collect them in California. So I always make this joke. So technically they're African-American clawed frogs, but the real name is the African-clawed frog. Let me tell you a story about the African-clawed frog before we start. Who's ever heard of it? Xenopus, it's called. It's like the #1 used frog in biology studies around the world for a really interesting reason. Here's the reason. Turns out in 1920, somebody discovered that the pregnancy hormone, HCG, that's required for you to maintain a pregnancy, so everybody here dependent on HCG, that hormone will make this frog lay eggs. This is a true story, you can Google it. So it turns out by 1940, this frog was the pregnancy test. If you thought you were pregnant, you'd go to the hospital and they would inject this frog with your urine, and if you were pregnant, the frog would lay eggs and then you'd be either happy or sad depending on your situation. So here's why I tell you this story, a couple of reasons. One is somebody, it was Lauren who just said science can be kind of silly sometimes, right? Who's the first guy who thought, I wonder what will happen if I inject pee into a frog? like how did that get discovered? That's sort of amazing. The second reason I tell the story is, here's the first reason you should care about frogs. When I tell you what atrazine does to frogs, you should remember that our hormones are so similar to frog hormones that our pregnancy hormone will make this frog lay eggs. So if I tell you what atrazine does to reproductive capabilities in this frog, you should be thinking, what about me? In addition to caring about the frogs in general. And that's where we're going to go. I'm going to tell you, what about you? So here's what we discovered. And I was originally doing research for a company at the time. They were paying the bills. And I discovered that if you raise these frogs in atrazine, their larynx, or their voice box, didn't grow. Here's why that's bad news. Again, the similarities are important. The reason that men have deeper voices than women is because testosterone makes our voice box grow, the male hormone. Frogs, the males sing and the females don't for the same reason. So the idea is that these frogs, their gonads, their reproductive parts, weren't making the hormone properly. So while still working, being paid by the company, we decided to dissect some of these frogs. We have to do that. And these are the kidneys. Their gonads are inside. Those are testes, so it's a male. But then this one had ovaries, then it had another testes, then it had more ovaries. Like there's a whole party going on. You didn't have to leave home, right? And we knew that's just, and that's not a judgment call. There's normally frogs, males are males and females are females. As you may know, there are fish that are naturally hermaphrodites. There are no frogs that should naturally look like this. So we knew there was a problem. So we proposed the following. If this big circle is a testis, or a testicle if you're a human, same thing, you should make testosterone. That's the male hormone. You know where that word comes from? Everybody's heard of testosterone, right? Who's the bicycler just got busted for taking extra testosterone? It's the male hormone. The word literally means testicular hormone, testosterone. That's the way the word comes from. Two words pushed together. So we proposed, you just heard about enzymes, we proposed that atrazine turned on an enzyme. And in this case, this enzyme aromatase is the enzyme, the machinery that converts testosterone into estrogen. Estrogen stands for estrus-generating hormone. So it's the female hormone. So if you're a male exposed to atrazine, your testosterone goes away. So you're demasculinized, you're chemically castrated. And you're also feminized because now you're making estrogen, which you should not be doing as a male. Females, yeah, it's a good thing. For men, it generates a problem. So we could measure that. So just like you can go to the doctor and have your hormones measured, we can measure that in frogs. So here's what control or normal males look like. That's their testosterone level. Here's what atrazine-treated males look like. And here's what females look like. So they are chemically castrated. I use that word a lot because the company doesn't like it. That's just the kind of guy I am. So we could prove that they were chemically castrated. Now here's the result of that. Okay, what you're looking at now are testes sliced real thin under the microscope. So just imagine I've sliced a salami. You're looking at one slice blown up. What you're looking at in the control, if I blow this section up, these are testicular tubules, just like we have, guys, filled with sperm. That's all sperm. And sperm need testosterone to grow. If you're exposed to atrazine, I'll blow this up. That's the testicular tubule, but that's just junk. Like you see all those dark things there? That's all the sperm heads lined up. And in this case, that's all just cellular debris or junk or garbage. All the rats got in. Break it down that way. Ate all the chicks. In this case, the chicks are sperm. That just sounded kind of gross, but you get the point. You get the point. Here's the other thing we discovered, and we've published all this now. This has all been peer reviewed. We discovered that when these frogs grow up to 10% of the males can completely turn into females. So, for example, we have a genetic marker, so we can tell only females have this little piece of DNA that's shown here. So that's a male. See the guy who kind of looks like he's smiling? And you can guess what he's doing. If you're not okay with it, I used to tell my 5th graders, this frog hurt its leg and that one's giving it a ride home. That's his brother. So about 10% of these males completely turn into females. So for example, this one lays eggs just like a female, even though it's a male. He, in fact, is a grandmother. He was completely converted because he made so much estrogen that he turned into a female. In other cases, we get animals that look like this. So this is gonads from a North American leopard frog, and these are the testes, okay? So those are male parts. And these I usually call a junk in the trunk. You know what all that is? These are eggs, that's right, that are bursting through the surface of this male's testes. Now, you just heard Lauren mention the EPA. I was involved with the EPA. And in fact, this was published in Nature. It's a big deal to publish in Nature. I sent this photo and these data to the EPA because they were reviewing atrazine. And they emailed me back, and it went something like, "Dear Dr. Hayes, thank you very much for the interesting data. However, we do not feel that this is an adverse effect that would trigger re-review for deregulation of atrazine." Now, here's the story I always tell. My wife tells me that there is nothing more painful in life than childbirth. And based on the grip she had on my hand when my son was delivered, I gotta agree. But guys, are you with me on this? A dozen chicken eggs in my testicle. Doesn't that seem like it should be somewhere in the top 5 or something? Right? But the EPA says it's not an adverse effect. The EPA says it's not anything to worry about, even though they had the data even before it was published. So we did some work, and we showed that this is not just a laboratory artifact, that frogs develop this way in the wild. And I'm not going to show you all of those data, it's all been published. But what I want to do is we talked about levels. I want to give you an idea of what levels we're talking about. First off, the effects of atrazine are produced at 0.1 parts per billion. That's 0.1 micrograms per liter. And if you're like me, that means absolutely nothing, right? You can't, how much is that? I don't know. Here's how much that is. It's 1/1000th of a grain of salt in a gallon. 1/1000th of a grain of salt in a gallon. That's what produces those effects. But believe it or not, hormones are active at 100 times lower than that. So while a toxicologist might tell you that's a low dose, to somebody who studies hormones, to an endocrinologist, it's a high dose. Here's the problem. The package of atrazine recommends that farmers apply it at 2.9 to 29 million parts per billion. So a typical farmer might be applying this stuff at levels that are 290 million times higher than we use in the laboratory. You can Google these numbers and pick them out. Here's the minimum and maximum detected in agricultural runoff, temporary pools, permanent water like lakes and rivers, and rainwater. Here's the level that we're using in the laboratory. So here's what would be at risk. There's enough atrazine in rainwater to produce these effects. In fact, it can go up on dust. Sound familiar? It can go up on dust, it can travel over 1,000 miles and come down into rainwater. The U.S. Geological Survey can measure atrazine in the rainwater in Minnesota from when farmers applied it in Kansas. That's why the European Union banned it. Because France banned it, and then it was coming over in the rain from Germany, so the European Union said, okay, everybody has to stop using it. And if it can travel over 1,000 miles, it can certainly travel during application, it can certainly travel in a dusty place. It can certainly travel in the rainwater even further than that. What's more is, here's the 3 parts per billion. That's what the EPA says is safe for drinking water. And you just heard Lauren talk about this 1,000-fold safety factor. That's because atrazine causes tumors in rats of the brain, I believe it is, at 3,000 parts per billion. So they divide it by 10, because they only use 1 strain of rat. That's a safety factor. They divide by 10, because a rat's only 1 species, and then they divide by another 10 just to be safe. But they never tested 3 parts per billion. They never looked for the kinds of effects that we looked for. They found 1 effect at a high dose and divided by 1,000 and said, okay, that's okay in your drinking water. That's where those numbers come from. And in fact, in many of these cases, Roundup is an example, in many cases, the safety limit is set at what they can detect. Lead's the same way. They regulate the chemicals, they go, well, we can't measure it below that, so that's the safety limit. And we know that that's not true. Even the hormone estrogen is active at levels that we can't detect. Our body is much better at detecting it. So you heard a lot about mixtures. This is a photograph from Nebraska. We got concerned with what happens with atrazine when you mix it with other chemicals. Okay? It's almost like Lauren and I planned our talks together and tag team on this. Here's what happened. We did an experiment on Salinas. And Salinas River runs south to north, and all the farms are in the north. And we wanted to know, and we don't know. We know that they're using hundreds and hundreds of chemicals. We don't know which ones on which farms, but we know that they all run off into the river. Again, that might sound familiar. So, for example, we did an experiment where we start upstream, upriver, and this is where rich people in California get their water from. It's in a place called Santa Margarita, and there's no pesticides and no other stressors. Then we went downriver. This is a place called Atascadero, and you just heard about physical stressors. So here they're physical stressors. So there's about 3,000 tadpoles in a pond there that has 1 inch of water, and it's about 100 degrees Fahrenheit. So they're physically stressed, not chemically stressed. Further downstream, the water's here again, because this water's all been drained off for agriculture. And further downstream, all that water is agricultural runoff. So there are no more physical stressors. The water's 2 feet deep, 20 degrees Celsius, but they're pesticide stressors. This is probably not true of Hawaii, but when I give a talk anywhere else in the US, I remind people that they've eaten from Salinas. 85% of the US's lettuce comes from this one little valley. That's only about a 2 hours drive. 85% of the country's lettuce. Here's what that looks like. If you go collect tadpoles down that river, this is one from Santa Margarita from the clean site. This is one from that inch of 100 degree water. And this tadpole, which also has an inability to fight off diseases, is loaded with parasites. This tadpole has no physical stressors. The only difference between this one and this one, they're the same age, same developmental stage, collected on the same day. This one lives downstream of water that's running off of our food. That's the only difference. Same temperature, same water height, same river, same age, same day, same species. But these tiny tadpoles are suffering from water. Here's where we collect them. That's surrounded by agriculture. Living downstream is kind of tough. So now the question is, why should you care about what's going on in California? Why should you care about frogs when there are no native? In fact, I got a call once, somebody who wanted to know if I could use atrazine to help get rid of the cocaine. I said, no, you don't want to do that. Here are the reasons why, if you don't care about frogs. This is actually from Lake Nabugabo in Uganda, another place I used to work. And this is a crop, I believe it's arrowroot. And the water that's running off from that crop is what the village uses for their drinking water, their cooking water, their bathing water. Here's why I showed this slide. If I told the villagers that the frogs and the fish in that water have reproductive problems, they can't make sperm, they have eggs in their testes, they have high disease because their immune system's been affected, the connection between environmental health and public health is clear because you're getting your water right out of, the water's running off your food, affecting those animals, and you're collecting it and taking it back home. The problem is, and maybe it's not the problem here, the problem with us is, I always joke, here's my village, this is Oakland, and my water comes from there, but it just comes out of a faucet. And we make these assumptions, like you just heard about, that there's safety levels and things that are protecting us. Well, maybe the people in this room don't make those assumptions, but the majority of Americans, I think, make those assumptions that they're protected and that the water is the last thing that they have to worry about. And it's probably true, we don't have to worry about coliform bacteria like you do in some other countries, but there's plenty to worry about. So this is a slide now. We're going to switch up a little bit. A colleague of mine that wrote in Epidemiology, so the study of disease in wildlife, the occurrence of an association in more than one species and species population is very strong evidence for causation. So what this person's saying is that if you find a chemical, for example, in the wild, and you find sick animals associated with that chemical, and you find that in more than one population, then that's support that that chemical is causing the problem. Okay? Correlation. What I just told you about, though, is experimental evidence, not just correlation. We actually have experimental evidence in more than one population, more than one species, more than one genera, and multiple families of frogs. Here's why you should care about frogs. The same things are true of fish, right? If you're living here with contaminated, agricultural chemical contaminated water running off into the Pacific Ocean and running off then there are going to be problems with fish, I guarantee you. Probably bigger problems than frogs. But other researchers have shown that there are problems with reptiles and birds, and then finally I'm going to tell you about mammals, of which we are. I'm going to tell you about not only correlations with poor health outcomes in humans, but I'm going to tell you about experimental data on rats and on human cells that have been done in the laboratory. First, let me tell you a little bit about Syngenta, the manufacturer. A couple things have happened. One is, here's a couple of news articles that have come out. Syngenta hired guns, attacked new documentary. There's a film that I was in to try to spread and make this information available. Here's another one, revealed how Syngenta investigated the press and shaped the news about the controversial weed killer atrazine. I've been the victim of personal verbal attacks. They've never physically attacked me, they've threatened to. And they just settled the lawsuit, and documents were made public that they tapped my phone, that they hacked my emails. They hired somebody to work up my psychological profile so that they could figure out how to harass me. And they actually wrote it down. Like, wait, you wrote that down? Hack his email. So I'm not just paranoid. This is real, although, there's that saying, the key to a successful life of paranoia is to keep careful track of your persecutors. And I'm kidding. Here's what I decided to do, though. Because they were attacking me, saying, oh, it's Hayes, he has an agenda, he's an activist, and he's crazy. I'm not denying the last part. What I decided to do was I emailed everybody in the world, and this is only a partial list, and I said, hey, let's all write a paper on atrazine so that the community, so that people know it's not just one scientist battling, it's not just one animal, one species. We want to know how broad are the problems with atrazine. And we represent now 20 countries, academic university scientists who've studied atrazine. We published one paper, you can see some of us here, there's about 12 countries represented. And here's some of the things that we discovered, and here's why you should worry about atrazine, even if you don't care about frogs. Remember I showed you frogs with sperm in the testis, you give them atrazine and the sperm goes away. There's a guy in Belgium that showed the same thing in fish. Give a fish atrazine and you can see there's no sperm in the testis. This is reptiles down in Argentina. This is like a big alligator called a caiman. See the testicular tubule, there's no sperm when it's exposed to atrazine. This is rats, mammals, like us. Here's a testicular tubule with sperm. Give it atrazine, no sperm. That work was done in Croatia and in Nigeria. And this is work from Pakistan showing that if you take quail, there's sperm in the testis, you give them atrazine, you can see that it's empty, right? Picture's worth 1,000 words. The other thing I told you is that the reason that the sperm is gone is because atrazine knocks out testosterone in frogs. So do you see that in other animals? Well, here's salmon. This is fish. This is what happens when you give a fish atrazine. There's no testosterone and there's no sperm. This work was published in England. Here's frogs and here's rats. You give a rat atrazine and his sperm count goes down. And rats, of course, are mammals like us. Now we're going to talk about humans. This is Shauna Swan's work from 2003. And here's what she showed. Here's atrazine levels in what she called controlled men. These are humans now. So she went around and she collected urine. I guess she had the men give them a sample of urine, give her a sample of urine. And then she measured atrazine in it. And men who can't get their wives pregnant and have low sperm count have significantly more atrazine in their urine. Now, that's a correlation. But we know that the sperm goes away when you give a fish atrazine, when you give a frog atrazine, when you give a reptile atrazine, when you give a bird atrazine, when you give a rat atrazine. testosterone goes down and the sperm goes away. And now this correlation says there's an association with humans as well. Does that make sense? Now I'm going to show you a trick. Here's a PowerPoint trick. The data is still there. I squashed it down. Because here are the atrazine levels studied by a colleague in California in field workers, men who work on the farm. Now I'm going to squash it down again. Here's the atrazine levels in men who apply atrazine to the fields. 2,400 parts per billion. So a man who applies atrazine in the field had atrazine